For the social context of our project, we looked at the location of where we would be implementing our solution, an aquaponics system. The location is Pemba Island, an island off the coast of Tanzania. We will be working with a local cooperative there called Tusuridu Nayumi. They have about 2 hectares of land available, and our prototype only takes up about 22 square feet. We also wanted to make sure that we understood the viewpoint of the citizens of Pemba Island. The biggest problems they face are hunger, poverty, and transportation. We want our system to be used as a supplemental food source, as well as a means to conserve their resources.
Stakeholder profiles allow us to understand who we're building the system for and how it will affect them. Our primary stakeholders interact directly with the system, and these would be the cooperative employees who are responsible for operation and daily maintenance. Secondary stakeholders interact with the system indirectly, such as the community members or consumers of the aquaponics products, or transport workers who would be transporting the agricultural products as well. Finally, key stakeholders are those who fit in neither of the previous categories but still have an interest in the final success of the project. This would include EPICS here at ASU funding the project, the Aquilibria team working on the project, Evo de Carneri, our community sponsor, and the Ministry of Zanzibar, which sets forth any health, safety, and ethical codes that the system must comply with.
It is essential to align the needs of the user to the interaction with the system. Overall, the co-op has basic tools to work with. The user scenarios consist of implementing the system with basic tools, integrating the media and the spinach, adding water to the tanks, and integrating the tilapia fish into the tanks. After the system is complete, the user will develop a team of maintenance and management, share knowledge between the co-ops, and lastly, sell the produce between the different co-ops.
In order to meet the need of our end user, we developed an aquaponics system capable of growing 120 leafy green vegetables and yielding approximately 20 white-Nile tilapia per grow cycle. Our research showed that this amount would be enough to supplement the diets of the nearly 80 members of the cooperative we're targeting. The system is metered by an Arduino microcontroller, which floods the grow beds with water and nutrients from the fish tank once every hour. The system is powered by voltaic solar panels due to the fact that there is no reliable source of power in the cooperatives.
Our objectives are to have better, cleaner crops, increase of economy, grow 120 bunches of spinach, and support 35 pounds of fish. We will implement this by building enough sufficient grow towers and testing them out before full use, and also teaching locals how to utilize the system, and they will use that as a job.
So the constraints in our system would be anything that would limit the scope of our project. Our main physical constraints were the pump, the height of the grow towers, the size of the tank, the square footage of our entire system, and the number of solar panels we included. Our main non-physical constraint is time. According to our Gantt chart, we had a time constraint of building the prototype by March 28. However, we didn't set realistic time constraints, so we weren't able to complete this deadline. Full implementation is supposed to be happening by February 2018, and that includes the pilot program. In terms of functionality, our system should be able to cycle through all the water completely. The pump should run once an hour based on our Arduino microcontroller. The solar panel should be able to power the pump, and the system should be able to grow plants and fish.
To put our progress into perspective, we can look at the work breakdown structure. Our goal is to take the concept of an aquaponics system and design a large-scale system on Pemba Island. Presently, we have completed the conceptual work from evaluating the needs of the island to drafting a statement of work. We have also designed a prototype and have yet to acquire the materials in order to build it. The first order of business at the beginning of the fall semester will be to orient the team and move forward with the prototype build. From there, the next steps are to develop an operator's manual and evaluation plan while refining the prototype. At the same time, the team will be raising money to take a trip to Pemba Island to launch a pilot system with the designated co-op. After the appropriate amount of time has passed with a successful pilot, the system will be scaled up for full implementation and spread to the rest of the co-ops on the island. We still have plenty of work to do before the close of this project, but we have made considerable progress.